Alright, in this video I'll be covering the natural logarithmic function and differentiation. Just some of the things that are going to be included are the natural log, the number e, and the derivative of natural log function. Here's just a graph of what the natural log function looks like. On the calculator, your natural log is this ln button. And so, just a few log properties that you should really commit to memory because you'll need them for these types of problems. Are 1, the natural log of 1 is just 0. 2, the natural log of a product is you can separate it into the natural log as a sum. So the natural log of the first term plus the natural log of the second term. Number 3, the natural log of a quotient. You can separate it with a minus sign. And the natural log of some term to the nth power. You can bring that n to the front and treat it as like a coefficient constant. So here I just have some examples for expanding natural logs. So the first one, natural log of 10 over 9, that's a quotient. If we look at our rules, if we look at our properties, then you can separate it with a minus sign. So that would be natural log of 10 minus natural log of 9. This next one, here we have, essentially it's natural log of 5x plus 3 to the 1/2. When you expand that one, you can bring this 1/2 to the front. (5x plus 3). And so this is going to be your expanded form. C contains both a quotient and a product. So the first thing we'll do is we'll just split it up from being a quotient. So natural log of 8x minus natural log of 3. That equals the natural log of 8 plus the natural log of x minus the natural log of 3. And that's our expanded form. Letter D, we've got a few things going on here, so we'll just start it off first by getting it all in one line. So natural log of x squared plus 4 squared minus, I'm using the quotient property, natural log of x squared plus 3 to the 1/3. You can bring this 2 around to the front because of the power rule. 2 natural log x squared plus 4 minus, you can bring this 1/3 out into the front. And we now have a I should have actually separated this out using the product property first. So natural log of x plus natural log of x squared plus 3 to the 1/3. I forgot you want to move from the biggest parts to the smallest parts. So when you have that, it's 2 natural log of x squared plus 4. Left side stays the same. Minus natural log of x plus, now we can bring this 1/3 out into the front of the natural log. And we have x squared plus 3 in the parentheses. And there's our expanded form. Just a quick thing of how to show just solving a natural log on your calculator. The natural log button is down here, so here we have natural log of 2, and that's approximately 0.693. Some derivatives regarding natural logs that you should know. The derivative of the natural log of x is equal to 1 over x, so long as x is greater than 0. Because if you recall the graph, x never goes less than 0. And the derivative of the natural log of u, that's for when you may have to use a u substitution. That's equal to the derivative of u over u itself. So just some examples. The derivative of the natural log of 2x. Here we'll have to, since we don't have the natural log of x, we'll have to define this as u. So if we define that as u, then the derivative of u equals 2. Remember that when you take the natural log of when you take the derivative of the natural log of some u value, you get u prime, which in this case is 2, divided by u, which is 2x. Your 2's can cancel out, and your answer is 1 over x. Example B, the derivative of the natural log of x squared plus 1. Once again, we'll have to make a u substitution. So if I define u as x squared plus 1, then the derivative equals 2x. So that equals u prime over u, which in this case is x squared plus 1. And there's our derivative. Wait, this is x squared plus 1. C, the derivative of x times the natural log of x. We're going to have to remember that when you take the derivative of something, you've got to use the product rule. So we'll have x times the derivative of the natural log of x plus the natural log of x times the derivative of x. So that equals, that's going to remain x times the derivative of the natural log of x is just 1 over x plus natural log of x times 1. Start boxing these. So when this all simplifies down, these x's can cancel out, and you're left with 1 plus the natural log of x. And then d, when we take the derivative of this, we're going to we're just going to use chain rule idea. So first thing, work from the outside and just move in. So bring the 4 out to the front. Inside remains the same. Bring the power down 1 times, now the derivative of the inside, the derivative of the natural log of x is just 1 over x. Simplify it a little bit and you get 4 times the natural log of x to the third all over x. Okay, so here's just another example. First of all, I'm just going to rewrite it as f of x equals the natural log of x plus 1 to the 1/2. And like letter D of our last example, we're going to have to use the chain rule again, but since we have this natural log in front of it, we're going to be using the idea that the derivative of the natural log of u equals u prime, oh, and you can't even see that, equals u prime over u. So first thing we'll do is this is our u right here, this whole part. So if that's our u equals x plus 1 to the 1/2. Take the derivative of it, and you get, just use chain rule, and you get 1/2 x plus 1 to the negative 1/2. So that means that f prime of x is going to equal 1/2 x plus 1 to the negative 1/2 all over, we're going to put it over our u, which is just x plus 1 to the 1/2. If you bring down, since this is raised to a negative exponent, then you can bring it down into the denominator, and since the 2 is on the bottom of this fraction, you can also bring that down to the denominator. So that's going to equal 1 over 2 times, when you bring it down, it's x plus 1 to the 1/2 times x plus 1 to the 1/2. So you add the 2 and you get 1 over 2 times x plus 1. And now I'm running out of time, so I'll be finishing up my last 2 examples and derivatives involving absolute value in the next video.